We'll kick it off here. Good morning, or good afternoon, or good evening, depending on where in the world you folks are. Uh, Thank you for joining this webinar, which is on AI and innovation. My name is Kartik Hosanagar. I'm a professor of technology and digital business at the Wharton School and one of the academic directors of our AI center, which is called AI at Wharton. So this program, as I mentioned, is on AI and innovation. I'm going to briefly make a few announcements and then introduce our first speaker. It's great to see that we are at 100, nearly 100 attendees here, so 99. So I'm sure we'll hit 100 at some point. So thank you all for joining. Okay, so first of all, I'd just like to briefly introduce our center. So AI at Wharton is broadly focused on the impacts of AI on business and society. Clearly, we all recognize today that AI is going to significantly transform work, productivity of organizations, even how things work at the macroeconomic level, at the societal level, and our center is focused on these issues with three main pillars. One is supporting research. So we support a number of research projects, both by Wharton faculty and outside of Wharton. Some of those research projects are described on our website, ai.wharton.upenn.edu. We have a number of industry engagements where we partner with various industry partners on both research projects where they bring their data or their research questions and we bring it to faculty who are affiliated with our center and pair those corporate partners with faculty conducting research in those areas, or also partner with them on events such as these. And then lastly, we have student experiences. We have a number of courses, not just for Wharton students, but for the broader population. So we've got a course on AI for business that is on Wharton Online. We've got a 4-course program on Coursera, which is on AI for non-data scientists, and a number of other programs on other platforms as well. And today's session, as I mentioned, is focused on AI and innovation, but we have a few others coming up. So for example, the next seminar, which is in June, which will be moderated by my colleague, Professor Stefano Puntoni, is going to be with author David DeCremier. And they will focus on some of David's ideas on what an AI savvy leader needs to be like going forward. So the theme is on AI savvy leaders. And then besides that webinar, we also have a conference coming up in May, which is called AI and the Future of Work. And we will have some excellent leading cutting edge research on AI and the future of work presented at that event, as well as some industry partners speaking there as well. So with that, let's kick things off. So the theme is AI and innovation. We've got 4 very interesting topics by 4 great speakers who all presented this research at our generative AI workshop last year. So we had a workshop in San Francisco, and we had 2 parallel tracks, lots of research papers. We picked 4 papers that were focused on innovation that we were excited about, and we requested them to join here. So the themes today, we have our first speaker is Léonard Boussioux, who is a professor at University of Washington, and he's going to talk about AI and creative problem solving. Next, we have Professor Dokyun Lee, DK Lee, who is a graduate from the Wharton School PhD program and currently a professor at Boston University. He's going to be talking about using generative AI to understand patent data and for patent market mapping. Next, we have Daniel Ringel, who is a professor at UNC Chapel Hill. And Daniel is going to talk about synthetic data in generative AI and its applications in market research. And then finally, we have Professor Rayna Xu, who's from Miami University, and she's going to talk about using ChatGPT, Google for search, and the implications of generative AI for search. So with that, I'll turn it over to Leonard to talk about AI and creative problem solving. Leonard?
Thank you very much, Kartik, for the kind introduction. And hi, everyone. I'm absolutely delighted to be here today to talk about generative AI and creative problem solving. So the work I'm presenting is joint work with my friends and colleagues at Harvard, Jackie, Miao Miao, Vladimir, Karim, and a whole amazing team. So before we get starting with the actual core of the talk, I would like to motivate why I'm super excited with generative AI becoming more and more popular, because I believe that it's an opportunity for us to accelerate problem solving around the United Nations goals. And those are 17 goals defined by the United Nations that we are meant to solve by 2030. And probably we will fall short of achieving them. However, I believe we can now accelerate problem solving, our productivity. And I'm very excited, for instance, if we select, for instance, sustainable cities and communities, you can immediately get some cool innovations using AI. So here I just input a little prompt, meaning I text with AI, and AI is going to render some content. And overall, that's an opportunity for us to solve big problems. So here are the research questions I will talk more about in this talk. How can Gen AI augment creative problem solving? What are the implications of Gen AI for human crowdsourcing of innovation? So the data I'm going to use to conduct this study is through a partnership with an AI company where we developed a crowdsourcing challenge about new business ideas on circular economy. We collected answers from a human crowd, but also by prompting ChatGPT-4 to get different kinds of solutions. And then we recruited humans on Prolific to rate novelty and value of every one of those solutions. So here are the key findings from our study. Every human and AI who had to generate something was in the format of a problem and a solution in the field of circular economy, so around sustainable development. And we leveraged the human intelligence by calling for those human solvers. And we also leveraged the human AI intelligence. So what I call human AI intelligence is a human prompting a large language model to get an answer. So it's a collaboration. It's not only about being AI alone or human alone, it's really this collaborative aspect. What's very exciting is, in fact, after conducting all the results, both the human intelligence and human AI intelligence ended up with the same creativity. So we define creativity by multiplying the novelty score by the value score. And it's exciting to see that both of them end up with the same kinds of results and performance. However, the human AI solutions have more value. And this is also interesting because through the pre-training, the alignment process, and fine-tuning of AI models, the answers are very well suited for value in terms of finances, but also environmental value. However, when it comes to novelty, meaning creating new ideas, it's really the human crowd that managed to get those novel ideas, especially the extremely highly novel solutions. So AI failed to produce very highly novel solutions, which was an exciting finding as well. So the whole study is motivated by the statistical view of innovation. The best ideas are statistically rare. So there is one method to increase the variance of idea quality and collect more rare ideas, and it's called crowdsourcing. It has a lot of success because you can access diverse knowledge and perspectives from many people all across the world. You increase the chances to capture extreme outcomes, so those rare, precious ideas. And often it's also more cost effective than developing new solutions in-house in a company. However, it also comes with challenges. For instance, it's hard to organize. You need to write a proper problem formulation such that people can participate. You need to incentivize people to participate. And you often end up with a lot of low quality ideas. This is why it's also an opportunity to leverage large language models because they're scalable. They can potentially bring diverse solutions thanks to the large pre-training. And it's an opportunity to augment humans through strategic prompt engineering. So potentially we can have equal creativity and maybe even better. So the big question is, how can we leverage Gen AI for creative problem solving? And so this is how we conducted the study. We received 125 eligible human solutions through a challenge that was run last year from January to May 2023. And then we took the exact same wording of the challenge, fed it to ChatGPT, and used additional prompting strategies. For instance, few-shot prompting, meaning we include several examples. Chain of thought, meaning we ask the model to think step by step. Role play, so we gave different personalities to the GPT chats. For instance, you're Elon Musk, you're Satya Nadella, you're Sergey Brin. Or you are some of the common solvers, like we give different personalities from common people who answered the challenge. And to evaluate, we recruited people on Prolific, screened them to make sure that they have some basic knowledge, and every problem solution pair was evaluated 16 times on average. So I'm in the interest of time, I won't detail all our prompting strategies, but I want to emphasize this cool one, where we tried two ways of prompting ChatGPT. Way number one, I'm going to open 100 different chats and ask the same question, and I'm going to collect one problem solution pair per chat. Way number two, I'm what we call single instance. I'm opening one chat and I'm asking ChatGPT 100 times in a row to give me a new solution, but different from the previous one, and if possible, better. So this is inspired from the prompt chaining mechanism, and it's similar to asking either 100 different humans to generate one idea or one human to generate 100 different ideas. So quickly, I won't present all the results. We ran a lot of regression models, but overall, here is what is interesting to witness. So if we compare the distribution of novelty and value among the different solvers, we can see that the human crowd is the only one to get top novel solutions. However, in terms of value, the AI solutions indeed show a better average. And although we tried a single instance and multiple instance, we did not capture more or less top novelty value. However, using one instance of ChatGPT asking 100 times to generate one new answer yielded better average creativity than the human crowd. So that was an exciting finding, and we have other investigations. And this brought us to the question of what would it take for Gen AI to generate novel ideas? It looks like that generating something novel is challenging. It's easy for AI to recombine ideas thanks to the whole training data, but it's harder to get moonshots. So this is, of course, something that is constantly evolving, and maybe we're expecting GPT-5, the power of leveraging multimodal data. So we are going to learn not only from text, but also images, sound, etc. Potentially multi-agent systems where you have different GPTs collaborating, and retrieval augmented generation. And here are the conclusions. Prompt engineering can produce creative outputs comparable to human solvers alone. We get more value from human AI, but the human crowd is still more innovative, which brings us to this future of creative problem solving, where we can leverage the cost-effective and scalable opportunity of Gen AI and think about the best synergy we can build together. And of course, it comes with challenges. Maybe we over-rely on large language models. Outputs may be not as creative compared to a whole set of humans. But this is why the key aspect is we want to augment, but not replace creative thought. Thanks a lot, and I'm happy to take questions.
Leonard, thank you. You can stop the screen share. Here's what we're going to do for Q&A. I request all of you to post your questions, not in the chat, but in the Q&A icon. And you can also upvote each other's questions. And I will allocate the last half hour or so, or maybe a little less than half hour, last 20 minutes or so for Q&A. So I want to make sure all of the speakers are able to share their works, and towards the end we will have Q&A, and our speakers are welcome to answer whatever is easy to answer in the Q&A box itself. Feel free to go in and answer there. Maybe one quick question, Leonard. Thank you. That was an excellent presentation. Lots of great ideas for how to leverage AI in crowdsourcing. One question for you is, given you're seeing different strengths of humans versus let's say ChatGPT, what do you think about the role of human AI collaboration in that? I mean, the human role was just writing prompts, but what might be a model for human and AI to collaborate to get the best trade-offs here?
So I love this question. And you know what? Right now, I just teach generative AI to students at University of Washington, and I can see so many psychological phenomena happening in the student's mind. There is AI guilt, for instance. A lot of people think that if they ask AI to do too much for themselves, they're losing control. They're not feeling the ownership anymore. So I believe that there is a lot of psychology aspect to enhance. It's not necessarily that you lose control. It's rather that the way you're going to solve problems is going to change. You're not going to spend as much time as before on a few little tasks. AI will do it for you, but you're now in the driver's seat. You're the one who will suggest, hey, I want you to do this, this, and this. And as an example, I gave as an assignment to my students, you have 30 minutes to build a web page. It's inspired actually from someone at your school. It's Ethan Molik. And the students were impressed to witness that they could end up with a beautiful web page in HTML, CSS that nobody knew, like this language, and they managed to do it. And they felt the ownership because they drove the AI model. They choose the design. So I believe that this is where we're going. The capacity to instruct AI to do things in different manners. And this is where you recover your ownership, and this is where you recover your creativity. It's engaging us into thinking differently. And that's a new skill to develop.
Okay, thank you, Len. So with that, I will turn it over to Professor Dokyun Lee, who is going to talk about the use of AI for patent mapping. And of course, before Dokyun starts his presentation, please feel free to post your questions for Leonard in the Q&A. And Leonard, please feel free to answer questions there. And I will come back to some of the questions that may be required discussion towards the end. Thank you, and over to you, DK.
All right. Thank you so much for hosting. I'm going to present Innovate, Generative AI for Mapping Patents and Firm Innovation. So you can find the paper at tiny.cc/innovate. This is a joint work with my student, Zhao Qi, and also one of Wharton AI Analytics, Professor Sani Tambe at Penn. All right, so I think everybody here knows the powerful capabilities of Gen AI. So let me just quickly go through this. But I think the biggest capability that, other than ChatGPT and producing, writing, and, now videos and all of that, is to learn to generate any complex object, multimodal business objects like images, document, patents, jobs, firms, portfolios, consumers, literally digital twin of anything with enough data set. And in doing so, learns object space and compositions and scale. And trained model can then map out the object space, which provides compare and contrasting and deeper insights, augment purposeful synthesis of new and creative objects. It could be idea, it could be patents, and do 1 and 2 at an incredible scale. So this is some evolutionary tree. It starts all the way from Word to Vec. Many mainstream LLMs like ChatGPT is in this side of the tree, decoder-only model, which means it works. All of these works by learning to predict next word in long word context. But decoder-only model, because it's only trying to figure out the next words, it doesn't have a understandable or manipulatable representation of data sets. So it's not appropriate for mapping or representing multimodal object that can provide comparisons and insights. So research question we asked here is, can we harness generative AI for meaningful representation of business objects to aid exploration, understanding, and action? And how is this representation, is it even useful? The answer is we use what's called disentangled representation learning via variational autoencoder transformer. It's a type of generative model, and that unlocks managerial actions that otherwise wouldn't be possible, as this representation provides granular and uncorrelated dimensions that define, which then you can use to define problem and business object space. So most importantly, one thing I want the audience to take away is that this disentangled representation learning is basically finding a space of a multimodal object such that each dimension is constrained, that the variation in these different dimensions only affects specific properties of underlying business object attributes. So I'll talk more about it. This next few slides are basically discussing this. So take a very simple example of disentangled representation learning of cylinders. You give algorithm 1 million samples of different cylinders, and you ask the algorithm, find me disentangled representation space so I can manipulate each dimensions to create any different cylinders I like. And we know as humans, we just need 2 dimension, right? So for example, the good disentangled representation learning algorithm will look at millions of cylinders and then see that, look, radius and height are the only 2 dimensions you need to represent and create any cylinders. Basically, these are not related, right? And changing radius does not change height. And this is a good representation. Now, bad representation of cylinders might find and embed them or find a vector representation of it in volume and surface area, which obviously they change each other. If you change one, it changes the other. Why is this even useful? Let me just go into even more simpler example. So we created this sauce jar problem. Say you have a cook named Tim just made an avant-garde dish with 2 sauce, peanut butter and vinaigrette. You know, peanut butter is sweet and salty, vinaigrette is sour and salty. So upon tasting, Tim finds sweetness and sourness just right, but it needs to be saltier. But with just these 2 sauce jars, you cannot really make it salty, right? Because you add one, it's going to either both change sweetness or sourness. So with salt, however, you can make it better. So disentangled representation learning, if you, let's say you do it for business. Now, if you're a Tim Cook at Apple and you want to enter healthcare market, you can apply techniques like ours to understand the technological space using patents or any other data set and figure out, you can actually look at competitors and map out their technical prowess and see where would you allocate more resources for research and development. For example, they might say, hey, we want to, I'm just making this up, but we want to compete against Abbott and Medtronic. And then they can see on patent space, well, we need to bump up diagnostic capabilities. Right? So this is basically what we're trying to do. So innovate, what it does, it finds a disentangled representation of patents, map patents text into interpretable. You can use claims data, spatial representation, and it gives innovation space from which we can actually figure out, compare patents, compare companies that hold these, and it spits out axis of factors of innovation that comprise these set of patents. Right. So lastly, well, not lastly, but what good disentangled representation enables you to do are any of these followings. So what could you get if you combine patent A and B, automate combinational creativity? How unusual, you can ask it, how unusual is a patent with respect to specific technological factor, which will be driven from the algorithm? What innovation factors increase or decrease over time? Rank companies in technological factor X, that's again driven from the data. If I'm firm A, what innovation do I need to boost up to be more like firm B? How do firms move in innovation space over time, and how does that correlate to some performance? What happens to innovation activity in specific technological region after event X, such as acquisition or mergers, and so on and so forth. So we just ran this on AI PD dataset. It's a US patent data on AI computing systems, about 500,000 patents. Let me just quickly go through. So these are some innovation factors, axes. Don't need to pay special attention to this. Let me just, first example, you can do combinational creativity. So you take a representation of the patents and you add 2, for example, using multiple search engines to search multimedia data and system and methods for rapid updating of credit information. And the algorithm is able to figure out that if you combine these 2, you may get something like process for protection against fraudulent use of smart cards. Right, so multimedia search and credit card fraudulent detection. You can also basically, for each of these innovation factor, rank companies and their technical prowess based on patents data. For example, electronic digital data processing, Western Digital Corp comes up top based on these patents. You can also, this is basically, if you're Google, you want to see technical prowess difference against, say, Medtronics. It says diagnosis is the top difference. I'm skipping this because this is going to take a long time, but you can look at the paper. We can actually explore patents and categorize them based on their how unusual they are, and categorize them into combinational, exploratory, and transformative type of patents. So you can use this technology for all kinds of multimodal objects. You can embed products in feature space and do the same sort of analysis. Products in which feature, brands and personality space, assets and risk space, jobs and skill space, firms and business strategy space. As long as you have a great amount of data, you can apply the technique. So takeaway, Innovate is an exploratory tool. This tool enables interpretation and comparison and visualization, something that deep learning and generative AI was not really known for, but this tool is built for that. Generative AI can be used to map out competitive landscape for strategic action. And you can find a paper here. I do have another paper on creativity and art that you can find here. Thank you.
Thank you, DK. Appreciate that. You can stop your screen share at this point. In the interest of time, I'm going to keep this moving. So I will again invite our attendees to post any questions for DK in the Q&A box, and I will turn it over to Daniel Ringel, who is going to talk about synthetic data. Thank you, Daniel.
All right, folks. Welcome. Thanks for such a great turnout. My name is Daniel Ringel from UNC at Chapel Hill. And I feel like a little bit of a party pooper after seeing all this amazing stuff on generative AI. I do acknowledge it's very important. However, what I'm going to show you today, what I contend is that we don't always need that mothership, that whole candy store that can do all these amazing things. A lot of tasks that we see in organizations or in firms are actually rather specific. But the question is, can we still leverage generative AI to help us on those? And that's what I look at. So multi-purpose AI, as I would call it, bigger, better, or maybe overkill. We have these massive models that are applicable to many tasks, and they promise to revolutionize knowledge work. Leonard showed us some really nice examples how this can really help in creativity and new solutions. So I acknowledge that. However, these models are very unwieldy, and they're hugely resource hungry, difficult to build, largely proprietary, centralized, and under control of few who we will depend on to some extent when we use the most powerful ones. So like OpenAI's GPT-4. Specialized AI has been around for a while. It's good for individual tasks. It's known to be effective, efficient, and accurate, but it does require a lot of expertise, knowledge from domains to train it. Example might be OpenAI's toxicity classifier. So even though OpenAI has this massive Gen AI system, they still use much smaller, much more narrow AI systems to kind of check and maintain integrity of their chats. So the question I pose is, why do you need to buy the whole candy store for many applications if you just need a lollipop for something specific? The example I'm using is natural language classification. So we are in a world, we are flooded with information, news, social media, customer interactions, reports, policies. And when sometimes we just need to have a specific piece of information in this vast flood of data. And narrow AI or classifiers can help us there. They can find specific topics that we're interested in, biases, sentiment, compliance issues, or emotions, and they're very versatile. So this gives us a very punchy way of looking at very specific problems or pieces of information that we're searching for. The thing about these classifiers is that they heavily rely on their training. And training an effective classifier requires a lot of labeled examples. We need to give this even specific AI a lot of examples of what we're looking for. And that's pretty easy if something is simple, like sentiment, let's say. In the marketing context, it's been used a lot. Most folks who are attending today would probably be very easily able to determine whether something is positive or negative. It's a lot harder when you're talking about complex constructs of interest that are multifaceted, that require domain expertise, experience, a deeper thought. And the problem is these domain experts are scarce and expensive, and most of them don't like to do mundane tasks as labeling data. So what do we do if complex constructs of interest might actually be more insightful? So think of consumer sentiment, which we've used in marketing a lot towards a brand. That's fantastic. However, what are people liking or not liking about the brand? Is it their product? Is it the advertising? Is it where they sold it? What was their experience? That's something that we might want to explore with something very specific. So what we could do is we could leverage generative AI to replace human experts, have like a synthetic or silicone expert to simply do this for us. It's easily accessible, right? We can connect through to the API. It is trained on vast amount of information, so it should have seen a lot of theoretically found constructs that we might be interested in. And this is the spoiler here. This works very well. The bad news is there are a lot of limitations here. The best models are largely proprietary. I've tried what I'm about to show you with non-proprietary models. It just didn't pan out so well. Those are rather slow and costly when you do this at scale, when you sift through massive amounts of information inside or outside your organization. And sometimes you have some challenges about reproducing what you just got. So this might not be appropriate for many research and production settings. So here's the idea of the synthetic expert. The synthetic expert basically says, well, there is a candy store and it has all that information, but how do we pull out the lollipop from the candy store? So the idea here is to say, well, we don't always need that vast body of knowledge. We need something very specific, just a tiny piece from it. So the idea is very straightforward. You reapproximate that vast body of knowledge, that powerful AI, for one specific task with an open source language model that we just fine tune on labels from that large AI. And whether that works and how that works is something I'll show you by an example of the marketing mix on social media. Now, social media is a source that marketing researchers have used a lot extensively in the past. Why? Because it gives us a lens on the hearts and minds of consumers, what's going on there. Sometimes we want to also know what's going on specifically. So if you look at the marketing mix, one of our core principles, product, place, and promotion, that's at the heart of marketing strategy. These are the levers we can pull. Now, the task here was to say, well, is this a difficult or not difficult task? I think it is. So we used human experts to identify in 1,000 tweets what they're really about, which of the marketing mix variables they're about. And they didn't have a lot of fun at this. We spent hours and hours doing this with 4 academics. Now we're going to compare that to a baseline. Could this be done by crowdsourced amateurs, just like sentiment? Or can GPT-4, a generative AI, do very well, as I proposed? And finally, what about just approximating that open AI, pulling out that lollipop from that massive candy store? And what we find is that crowdsourced labels don't really agree very well with the truth of human experts. So we can't really crowdsource this. However, GPT-4 is a viable surrogate for this human expertise without any further fine-tuning, any more manipulation, because it knows these constructs of interest. More interestingly, however, the synthetic expert is only 2.5% less accurate, but 66 times faster and 400 times cheaper, which makes this a very scalable solution. And this is just on my MacBook. So I don't have to run this on a dozen H100 GPUs somewhere. I can run this on my MacBook. I can even I tried it running on a Raspberry Pi. So what's the implication? Well, if you daisy chain multiple experts, multiple classifiers, you combine them, just as you would say, the mothership deploys its troops with different skills, we can get deeper or richer insight. So in this case, if you look at something like competitive brands, their overall sentiment might be very similar, but when you look at it on which parts, the product or how they promote it or where they sell it can be vastly different. So there's more richer insights for us marketers to be gained here at scale. Now, what's the implication? By pulling that lollipop out of the candy store and making it yours, you're removing all the strings that are attached. You're mitigating some of the privacy confidentiality concerns. You can easily update it and scale it. And for research, we have a fast way of getting more interesting complex constructs of interest that we couldn't identify earlier inside our models. It's fast, it's cheap. You can share it online, which I did. There's one marketing mix classifier now, over 2,000 sentiment classifiers, a little easier to train. And it's very fast, it's very cheap. You can extend that to many things. Marketers can look at branding or SWOT analysis, dimension of service quality. Lawyers might look at contractual elements and tons of text. Policymakers look at government documents or organizations. whether this is morally questionable or not, could study all the communications from their employees to identify leadership styles. So many opportunities here. Future innovations in AI will probably improve this further. Our ability, this is the very bottom baseline, and extend it to different media types. You can play with this. I share the code, I share the models, I share everything openly. And thank you all for listening to my talk.
Thank you, Daniel. One quick 1 minute type of question for you before we move on. The question I have is, there's a lot of work involved in creating a customized, specialized model for your task. And maybe you can get it to be slightly better than a more general purpose model. But those general purpose models, so much money is being poured into those. A new version will be released in 6 months, 9 months, that probably will beat your specialized model. So what's your take on the R&D costs of building special purpose model when those generalized models are improving rapidly with each iteration?
Well, first of all, as they improve, you're going to be switching between generalized models back and forth. There's going to be a race. Mistral might be better, then GPT might be better. Regardless of which one you choose, you can always rapidly train your synthetic experts anew with the newest model, and that will also improve it again as the label quality gets better. Secondly, no matter what you do at this point, these large models, to keep them as powerful, need vast resources. And your synthetic expert is going to be much faster. It's going to be local, under your control, and it's going to be a lot cheaper. So there continues to be an advantage in efficiency, cost, and accuracy.
All right. With that, and to keep this moving again, I will turn it over to Rayna to talk about ChatGPT versus Google for search.
Thank you for the introduction, Kartik. Let me share my screen.
And folks, you can continue to post questions for any of our speakers in the Q&A box.
So hello, everyone. Today, I would like to share with you the results and insights obtained from our research project. It is a joint work with Catherine Fang from Poly U and Hailiang Chen from Hong Kong U. Well, the three speakers have already shared their great insights on how Gen AI impact pattern data analysis, artwork creation, and natural language classifier. And we all have realized that Gen AI is on its way to revolutionize many aspects of our everyday life and work. And information search is one important aspect. So in this study, we aim to investigate how Gen AI impacts user search behaviors and performance compared to traditional search engines like Google search across various search tasks. And our study presents the first comprehensive comparison of performance and user behaviors when using ChatGPT and Google search engine in the context of information retrieval. We conducted 2 randomized online experiments. We firstly directly compare user search behaviors and performance when using ChatGPT versus using Google search engine. As now it's becoming a trend to integrate both tools for information search. So we conducted a subsequent experiment to examine the effectiveness and the strategies of using both tools as opposed to using just one. And based on the results, we further explore the mechanisms of using different search tools on task performance. Well, due to time limit, I will not go into the details of our experimental design, and here is a summary of our results. First of all, we find that users tend to spend less time on all tasks while using ChatGPT, and there's no significant difference in overall performance. So which indicates that utilizing ChatGPT, users are able to enhance their search productivity. Additionally, users perceive ChatGPT offering better user experiences in terms of usefulness, enjoyment, and satisfaction, while they perceive both tools easy to use. In terms of search efforts, although that users spend similar level of efforts using both tools, but users tend to use longer queries while interacting with ChatGPT because users tend to provide more detailed prompts compared to the keyword-based queries. And intriguingly, we find that the performance of using ChatGPT versus using Google is task-dependent. While ChatGPT excels in answering information lookup questions, it struggles with fact-checking tasks especially fact-checking the nuanced or conflicting information. And we further find that users who have a higher belief in the accuracy of the search results using ChatGPT tend to have lower performance. And additionally, participants' perception in search fluency, over-reliance on the search results, and the prior experience using ChatGPT tend to lower their performance on fact-checking tasks. And when both tools are available to users, they are able to achieve a more stable performance with intermediate search performance, search efficiency, and efforts. So the dual tool usage actually compensates for the limitations of either tool. And also interesting, we find that users actually strategically choose different tools based on the task types. So there, for example, for the fact-checking task, users are able to tend to use Google search more. While for tasks which evolve with information lookup or evolve with solving a technical problems, users tend to use ChatGPT more. And our results provide implications for both search users and search service providers. For search users, our results show that users can leverage generative AI to improve their search productivity. However, when using generative AI tools, users should avoid over-relying on the tools for fact checks, and cross-validation is often needed. Additionally, we will recommend strategic use of different tools depending on the task types. For example, based on the open-ended questions in our experiment, we find that users perceive ChatGPT advantages in completing tasks with unfamiliar topics or tasks that requires personalization or specificity. However, for tasks that require source tracking, Google has an advantage in providing references. And also for search service providers, our results show that it is beneficial to integrate Gen AI technology into traditional search engines because the dual tool usage generates more stable performance with intermediate search efficiency. However, the efficacy of dual tool usage may depend on task natures. When a single tool meets a task demands, introducing a secondary tool may not provide added value. So for example, users use Google search to do fact verification. Introducing ChatGPT may not necessarily increase the performance. And due to some the inaccuracies or inconsistencies in the result provided by ChatGPT, sometimes it may lower the performance. So a good design strategy may involve recommending specific functionalities to users based on their queries. And also because we find that users interact with these tools differently as reflected in the differences in query length and format. So it is also important to consider these behavioral nuances when integrating these tool functionalities. And last but not the least, it is prudent to alert users to possible inaccuracies within the responses. For example, when we design the user interface for the search engine, which is beneficial for users to remind them to do cross-validation and which will facilitate their performance in fact verification. Well, that's all for my presentation, and thank you all. If you have any questions or if you want to discuss more in detail, please feel free to send me an email.
Thank you, Rayna. You can also stop screen share when you get a chance. There's a question that was posted in the Q&A, and I'll begin our Q&A discussion with that question for you, Rayna, which is, you haven't commented much about the fact that, say, ChatGPT or any LLM is not continuously trained, but it was last trained whenever. And so it's not as current relative to, say, Google search. So what are your thoughts on that aspect of information lookup, which is that the LLM is not usually current?
Well, that's a great question. We have an interesting finding that, well, because our experiment is conducted last year, so we are using GPT 3.5. And it turns out that now with GPT-4 and GPT-4 Turbo, we find that for certain fact-checking tasks, these advanced models actually perform better than GPT 3.5. So we believe that with the advancement of this Gen AI technologies, ChatGPT can become more and more capable in doing fact checking. But still, I think that due to the nature of the Gen AI technology, it tend to provide inconsistent result, and especially for tasks that require exploration and addressing conflicting information, still may not be as good as using Google search engine.
Okay. Yeah, and I think maybe potential insight there also lies in how Bing is leveraging not ChatGPT, but GPT-4 on search, or Google is trying to integrate LLMs into the search, which is to really combine the two and to use standardized information retrieval or search capabilities when the nature of the query is such that it is either current or there's a range of opinions on different websites, versus more factual, as well as questions that can be answered from the past. So maybe that's also one more way to look at it, which is that maybe the future is not either or, but in a unified interface which combines the two.
Yeah, agree.
The other one that I want to bring up is, I think if I combine the 4 papers, there's interesting takeaways in terms of how generative AI can be leveraged for innovation in general, whether it's idea generation like with Leonard, or understanding the space of ideas like with the market mapping like with DK, or information lookup with specific questions during the innovation process like with search. And there is, of course, the question of trade-offs when using generative AI. The trade-offs include privacy, and Daniel mentioned how specialized models, perhaps open source models trained on your custom data, gives you that privacy, and that trade-off is addressed. But there are other issues as well. Some people have brought up hallucinations as a potential challenge here. I'll start by asking DK this question of, what do you see as the potential flaws or things to watch out for when leveraging generative AI, whether in the context of your mapping the patent space or more generally in the innovation sphere? What would you want to be careful about?
Yeah, so these are very fascinating. So just to talk a bit about the hallucination, I think it's also in the question. So it's actually easy to program purposeful hallucination. There has been papers since 2017. There is something called a creative adversarial net, which basically was, that was 2017, to create an abstract form of art that deviates from everything else. Now, the problem there is, how do you make sure that the value is there? And that's always been the problem. How do we, and that's where the humans come in to provide value, that this is valuable, this is not useful, and things like that. Sorry, I forgot your original question.
Yeah, I guess the question is, what are the drawbacks of leveraging generative AI in these?
Right. So I think it's I think the biggest part is the biggest challenge right now is to, again, what I just talked about, the filtering. How do you scale efficiently to provide, generative AI can provide, novel ideas. Novelty is the easy part, but the challenging part is, how do you make sure that things are valuable, right? So I think that's the challenge.
Okay, so we have 9 minutes. So I'm going to pose maybe a question each and request 2-minute answers so we can cover one question each. And since I have DK on stage here, DK, one of the questions for you is, how do you think DRL impacts competitive fairness? Specifically, if we have a solution like yours, Innovate, to map the patent space of ideas, does that help the large companies more in terms of getting into new markets? Or is this a tool meant for startups and individual inventors and so on? Who do you think benefits from these kinds of tools is a question that Hyo Yang posed.
I think that's a very relevant question. I don't have a good answer for that, because these kind of tools have not existed for a while. And I think it takes a long time for these tools, for firms to act based on these insights from these tools, right? So this entangled representation learning is only a few years old. And so we don't know if the firms are actually using it or not. And most of the times firms are not using it. Having said that, this necessarily leads to having a better data or technology lead to market dominance. I'm not sure if that's clear because, OpenAI versus Google, right? That's a classic example. You had like Zillow, for example, had the best data in real estate, but failed in iBuying market. So I think that's an empirical question left to answer. We'll have to see. But I think these tools, it's accessible as long as you have a good prowess of the algorithm and which data matters, because we know it's not more data that matters. It's actually quality data that matters.
Okay, thank you. Next, a question for Leonard. I'll combine two questions. There are many clarifying ones. I'm going to skip those and maybe you can answer them offline. But one question by Michael is that sometimes you want, and often you want iterative incremental improvements rather than moonshot ideas. And so what's your take on, generative AI for that? And piggybacking on that, I'll bring up Vinay's question. You focused on sustainability. How do the trade-offs change if we go to other problem areas?
Absolutely. So I love those two questions, and I will share one slide to answer the first one, is that when we collect a lot of ideas or when we generate as a human many ideas, we often end up with this sort of bell curve. And there are several things to do. For instance, you want to filter out all the poor ideas. You want to eliminate the bad apples. It's very costly and it's really time consuming to do this. So many incubators or people collecting ideas, they have to do this manually. So that's one opportunity for AI because it's actually not too hard to filter out bad ideas. And Gen AI is a good way to do it. So we're doing research on this. The other part of the question is, how do I get to enhance ideas? And TK mentioned this, that if you keep pushing too much or looking for moonshots, you may lose your value because you're too novel and out of touch with reality. So what we are looking into is, can I have Gen AI refining little bit by little bit and improving the ideas? So we're building some early tools for this. So for instance, here I'm sharing a dashboard where we have all our ideas from our data set. And if I click on one of the ideas, I am going to have different criteria, more refined, to discover what could be good. For instance, around circular economy, are you meeting all human-defined criteria? And then we can use some classification models based on other kind of AI techniques and natural language processing to evaluate that. And we can also compare every idea with neighboring ones. And that's an opportunity to have a whole, for instance, this one is not as good. And it's also about electronic waste and how to recycle. And several ideas could have similar patterns, but they're not necessarily as good. And we're looking for now more fine-grained ways of evaluating this without needing to ask humans to always evaluate, which is costly.
Yeah. Okay, thank you, Leonard. Question for Daniel. It was posed originally in the context of Leonard's paper, but you could answer it in that context or more generally. And the question was about many of these tasks require some proprietary data or maybe large-scale data from the web and so on. So if you look at Leonard's task of coming up with ideas on sustainability, then maybe there's training data in the model that has looked at, web data on sustainability and related topics. And you can pick any other domain where you have some training data. And the question is, what is the role for synthetic data in these tasks? And the question I'll pose to you is, more generally, you looked at labeling using generative AI. But in general, what do you think about the pros and cons of using generative AI to generate synthetic data? For example, in our workshop last year, we had people using generative AI for answering surveys and things like that. So any take on where does that synthetic data prove to be valuable? Where does one need to be careful?
Well, that's a great question, and we see a lot of research on that front, trying to use some synthetic consumers, etc. For my purpose on the synthetic experts, I released a data set which I called synthetic twin. So I asked the generative AI to take original content and anonymize it, remove any identifying information, and create more examples of the data. Now, that's not exactly what you were asking. You're asking maybe using it as respondents to a survey, etc. But one use case is that you can create more data, more variations of data with giving it one seed, and then you can train your models on that. Now, to your question on the surveys, I would be careful. These large language models are trained on certain data that we don't know. There might be bias to certain responses, and they are trained on some kind of average over a long period of time. If I'm doing it for contemporary research, I'm always a little worried that I want to know what's going on right now. I want to do something. I want to see what changed, and I might not be able to do that with synthetic responses from a model that tries to find some good average across a longer period of time of all of its training data. Nonetheless, I see that it's a great example of where you can use rapid experimentation and getting some predisposition from historic data of how, if you prompt a model, how a consumer, for example, would respond to a survey question.
Got it. Thank you.
I think DK has a comment on this, right?
DK, did you have a comment on this?
Yes, it's also going back to your original question, what should we look out for? So we have a working paper on this. Basically, how do you use a Gen AI to replace humans? So there are a lot of things to be aware. It's basically just trained on currently text data mostly, and then multimodal too, but that's like 5 trillion to like 15 trillion tokens, which doesn't have, it's just only very fraction of like what humans know. So, you know, reasoning ability, it's still lacking. It doesn't have access to all these like contextual knowledge, common sense that we know, that we grew because we're grounded biological beings to the world. So there will be like the generalizability is very much in question. Just, yeah.
Okay, wonderful. Thank you. I see many more questions. I see we have only a minute left, at which stage I'm going to say there's no point in my asking a question right now, and I'll instead try and wrap up and talk about next steps here. So in terms of next steps, first we'll post the recording to this session online, and we will share the recording on LinkedIn and on our website. So please look out for that. It might take us up to a week maybe to get the recording ready and posted. So you can follow AI at Wharton on LinkedIn and you'll find the link there. In addition, we'll post the the papers and the presentation links as well. So to the extent the authors are willing to share those links publicly at this stage, I imagine so, and if so, we'll share those. And there are many more questions that were posed here. And I think it might be interesting to take some of that discussion online to LinkedIn or to Twitter, so you can even post some of those questions there. And I'm sure our authors here will be happy to comment about those. And I will also post a blog post bringing together these 4 different papers and comment on it. And I'll do that on my Substack. So that is hosanagar.substack.com, which is focused on generative AI and its applications and business implications. And hopefully, it'll take me a few days, but I'll post one, not in any one paper, but really some very cool takeaways that for me on innovation and these 4 papers coming together. So with that, thank you all for joining, and thank you in particular to all of the researchers who presented their papers. So thank you, and we'll see you at the next event.